Welcome to our second edition of Mathematics, Workplace Mathematics in the PM. This is Workplace 30. 2.2 is tolerances. First thing, hopefully you remember something about fractions. Maybe you do, maybe you don't. But the most common fractions in measurement are out of 2, 4, 8, and 16, because that's the way inches work. You guys ever work with inches and stuff like that much? An eighth of an inch, stuff like that, a quarter inch, 3/4 of an inch. You know what I'm talking about? You do? Yeah? Nope? Okay. Well, they are. Anyway, so I'm going to stick to usually even numbered fractions because that's usually what you end up working with. You don't have to go out of 17, but you will have 16ths or 30 seconds, sometimes even, depending on how accurate it is. Do you know how to do this? Add these fractions? Do you? Kind of? What do you need to have the same before we can add these? Same denominator, same bottom. So 1/16, that's the higher number. 4 can multiply up to 16. What do you have to multiply the bottom by to get 16? That's what you ask yourself. 4 times 4, right? So then that turns into 3 times 4. Does this ring a bell? I'm asking you to. Do you kind of remember doing this? Yeah. So what do? I'm thinking times 4, I'm thinking times 4, because that makes it 16. So this is going to be equal to 1/16, that stayed the same, plus 12 out of 16, 13 out of 16, which I'll leave. Same kind of thing with minus 3/4, multiply top and bottom by same numbers, except you're subtracting this time. I'll give you a second to do the second one. Because there's not much to do on this section here, and then we're done this section. Here we good? 3/16 as well, Faith, right? You good? Okay. Okay, let's read about working with tolerance because there's more to read than anything. When building or assembling an object, from a simple bookcase to a complex computer, you've got to take measurements. Measurements should always be as accurate as possible, and they should be precise enough for the needs of the project. If you're cutting lumber to frame a house, you're not building a watch. You don't have to worry about cutting to the nearest 16th, stuff like that kind of thing. But if you're building a watch, you actually need to be that precise, 16ths and 30 seconds. When manufacturing a product, a range of sizes is often acceptable. For example, if you're making a mortise and tenon joint as shown below, that's where it slips inside here, right? To have it small enough to fit inside the mortise, but large enough that it won't fall out. See, you know, you ever try putting a box lid, sometimes it's just too tight, you know, that kind of thing. You don't want it too tight, but you want it just right. The range of acceptable values is called the tolerance. So the tolerance is like plus or minus. How big can that be? How little can it be? There's a small wiggle room, basically, we call it the wiggle room. The tolerance is determined by subtracting the minimum acceptable value from the max value. The target value, usually halfway in between the minimum and maximum, is called the nominal value. Okay? There's 4 ways to write this, and you're going to be familiar with these. You could give both the max and the minimum value, top and bottom. Or you could say whatever the nominal or the average value is, plus or minus half of the tolerance. We'll get to an example. Or else sometimes they give a minimum value and say how much it could go up, plus the tolerance. Or a maximum value and how much it could go down. That's minus the tolerance. All 4 will give you the same information. And right away, you'll see how that works there. Okay, any questions there? Okay. There's very little to do on this. So here it is. Mackenzie's making caramel candies. Recipe says use a candy thermometer to monitor the temperature of the sugar mix. If it's not heated enough, the candies will not hold their shape. If it's heated too much, the candies will be too firm. The sugar mixture must be heated between 245 and 50 Fahrenheit. That's what ovens are usually at. So what's the temperature tolerance of the sugar mixture? How many degrees can it go up or down by? You do the math in your head. What's the highest and lowest? And how much is that spaced apart is really what you're saying. So, Tia? Well, it's both of you actually. I just had to pick one first. So, what is the tolerance? It's looking how much wiggle room can you go. It has to be between 245 and 250. So the tolerance is 5 degrees. Does that make sense? Max minus the min, highest and lowest. So I know the math isn't tough. It's what does tolerance mean? It's how much up or down you can go. Now, right? Pardon? All right, thanks, not Celsius. You're so smart. Big difference. Okay, Cookie. 4 different ways to write these. Go ahead. The information above. I'm going to just flip back and forth. Remember? One way is to give the maximum and minimum value, right? That's already kind of done for us, but how about this? I'll go minimum, maximum. Is it that way stacked, I think? The max? Oh, max over min, I think. This method is 250, as you would mention, you know, Fahrenheit, over 245. So that method, how does that work? That's how it works. Other method, the nominal value, the average value, plus or minus half of the tolerance is, so this method. What's the average of 45 and 50? 245 and 250. What's the midpoint of it? What's right exactly in between 245 and 250? Kind of. 0.5. Yeah, 0.5. Now, how could you find that, though, if it was too complicated to do in your head? You guys know how to find the midpoint of two numbers? I'll show you. If you need to, you go 245 plus the 250. And you get, well, that would be 295, or 495 minus 2. And then you divide that by 2. And then you say, well, 495 divided by 2 is, as you guys mentioned, 247.5. Thank you, Trent. So the nominal value, the midpoint value in between 245 and 50 is 247.5 degrees Fahrenheit. Plus or minus, though, the tolerance, half of the tolerance. And I think you know what half the tolerance is, half of 5, right? I'm using blue just so you can see where it came from, right? Half of that value. Okay? Now, do you see that that adds up to or subtracts down to 245 and 250, right? You add 2.5, you subtract 2.5. Okay. What about 3? The third method is where you give the minimum and then the plus tolerance value minus 0. That method is, well, what's the minimum? 245. They could say as high as plus 5 more degrees, but no lower than that. And then the other method is just the exact opposite of this one. The max. Plus nothing, subtract the tolerance, is 250. Sort of like that. Now, I'm thinking that this isn't too shabby. I'm going to just stop the record.